Okay, in section 3 here, we're going to start looking at solving trig equations. And really, solving trig equations got the same goal as solving any other equation. We want to get the variable to be isolated. And to do that, we first have to isolate the trig function itself, and then use the inverse function in order to isolate the actual variable. Okay, so let's look at some examples. First example is the equation 2 sine x minus 1 equals 0. And over here on the right-hand side, we have this restriction that we want our solutions to be between 0 and 2 pi. Okay? So we need to start by isolating the trig function. So we're going to have 2 sine x equals 1, which means that the sine of x is equal to 1/2. Okay? So now how do we get the variable by itself? Well, to get the variable by itself, we take the inverse of both sides, which means that x would be the inverse sine of positive 1/2. And remember, what that means is that the sine of some angle is going to be 1/2. And what is that angle? And since we're talking about the restriction of between 0 and 2 pi, what angles in the first rotation of the unit circle had a sine of 1/2? Well, the sine is positive in the first and second quadrant, and a sine of 1/2 would put me at pi over 6 in the first quadrant, and 5 pi over 6 in the second quadrant. So those become our solutions to the equation 2 sine x minus 1 equals 0. Okay. Let's move on. 2 cosine of x plus 1 equals 0. This time our restriction is from 0 to 360 degrees. So now we're going to be able to give our answer in degrees because that's how the restriction was set up. So again, we want to start by isolating the trig function. So we'll take 2 cosine x equals negative 1. So cosine of x is negative 1/2. So x would be the arc cosine or the inverse cosine, however you prefer to write it. You'll probably see both, of negative 1/2. So what values of x are going to have a cosine of negative 1/2? Well, cosines and 1/2, that goes with the 60 degrees, but the cosine is negative. So where is cosine negative? It's negative in the second quadrant, which would put us at 120 degrees, and it's also negative in the third quadrant, which would put us at 180 plus the 60, or 240 degrees. Okay? Meaning that the 60 degrees is our reference angle, if you remember those. Okay, it's all referring back to that 60-degree angle. Problem. Sine of x plus square root of 2 equals negative sine x. So just like any other equation, we have to collect the variables on one side. So we're going to move the negative sine x, and we're going to add sine x to both sides, which would give us 2 sine x plus square root of 2 equals 0. And I need to isolate the sine. So 2 sine x equals negative square root of 2. And I would have sine x equals negative square root of 2 divided by 2, which means x is the inverse sine of negative square root of 2 over 2. Okay? So the sign is negative, okay, which tells me I'm going to have to either be in the third quadrant or the fourth quadrant, and the negative square root of 2 divided by 2, okay. We don't have any restrictions on this one, so we're going to go with radians. Remember, square root of 2 over 2 means that I will have my reference angle being that pi over 4 group. Okay. So since I'm going to be in the third quadrant, that means I'm going to have 5 pi over 4. And in the fourth quadrant, I would have 7 pi over 4. Okay. Now, notice there was no restriction on this problem, which means there can be more than just those solutions. I don't have to stay between 0 and 2 pi, because remember, these trig functions, they just repeat and repeat and repeat over and over and over. So to show that, just like finding coterminal angles. Remember, coterminal angles, I would add 2 pi. Okay? And to show that I'm going to keep adding 2 pi as many times as I want, I'm going to have 2 pi n, where n is some integer. So I have 5 pi over 4 plus 2 pi n gets me all the angles coterminal with 5/4 pi. And 7 pi divided by 4 plus 2 pi n gets me all the angles coterminal with 7 pi over 4. Okay? And this is what we call a general solution. Okay? Where we're adding those multiples of 2 pi to get all of the coterminal angles that would have those same values. Okay? So if there's no restriction given, then you're going to have to use these multiples of 2 pi, these 2 pi n's, with your solutions to show that there are repeated solutions. It's just going to have an infinite number of solutions. Tangent of x equal plus the square root of 3 equals 0. Again, no restriction. So we're going to go tangent of x equals negative square root of 3. So x is the inverse tangent of negative square root of 3. Okay. So again, we have to decide what are we talking about in terms of a reference angle. Okay. So what would the reference angle be if my tangent is a square root of 3? Well, if I go back and think tangent is y over x, and that would have to be square root of 3 over 2 over 1/2. So that's going to put us back at that 60 degree or that pi over 3 category. Okay. So our reference angle is pi over 3. Okay. Now the tangent value is a negative, so where is the tangent going to be negative? It's going to be negative in the second quadrant and in the fourth quadrant. Okay? So in the second quadrant, a reference angle of pi over 3 would give me the angle 2/3 pi. And since it's a general solution, it would be plus 2 pi n. In the fourth quadrant, the reference angle of pi over 3 would give me the angle of 5/3 pi. And being a general solution, I would add plus 2 pi n, so that I would get all of those angles coterminal with the 5 pi over 3. And up here I'm going to get all of those angles coterminal with the 2 pi over 3. Okay? And that's what these 2 pi n's on the outside here are doing. It's getting us the coterminal angles with the initial angle that we found. Okay? Next equation, 3 tangent squared x minus 1 equals 0. So again, we need to get the trig function isolated. So 3 tangent squared x would equal to 1, which means tangent squared x would be 1/3. And now to get rid of the square, I'm going to have to take the square root. So tangent of x is plus or minus the square root of 1/3, which is plus or minus square root of 3 over 3. Okay? So x is the inverse tangent of plus or minus square root of 3 divided by 3. Okay? So again, we have to think about which family of angles is that going to put us in for our reference angle. Okay? Well, the square root of 3 over 3 with the tangent is going to put us at a reference angle of pi over 6. And since I have plus or minus, I'm going to actually end up with all of those angles in that first rotation that have that value. Okay? Now, the inverse tangent, remember, is really only defined from negative pi over 2 to pi over 2. Okay? When we talked about those inverse functions. Okay? Which means to get that square root of 3 over 3, the positive value would give me a pi over 6. The negative value would give me a negative pi over 6. Okay? And the period of the tangent function, we didn't really talk about it a lot because we didn't do the graphs, but the period of the tangent function is just, not x. Find an eraser here. Okay. The period of the tangent function is pi rather than 2 pi. So I'd have pi over 6 plus pi n and negative pi over 6 plus pi n. Okay. Now if we would have had some restriction on it, then we could have maybe looked at that a little bit differently, but without having the restriction, we have to go with the way the inverse tangent is defined. So that's why we have to keep our values here, okay, have to be within this range. Okay. And cosecant squared minus 2 equals 0. So again, we're going to get the trig function by itself. So cosecant squared x equals 2. And I'm going to take the square root of both sides, giving me cosecant of x equals plus or minus square root of 2. So x is the inverse cosecant of plus or minus square root of 2. So we have to think about now, what is our reference angle going to be? Well, which angles have cosecants that are going to be square root of 2? Okay, that's going to come from that group of pi over 4. So again, there's no restriction here, so it means I have to get all of the values because it's a plus and a minus. Okay. So if the cosecant had a positive square root of 2, then that would put me in the first quadrant at pi over 4. Because remember, cosecant is the reciprocal of the sine, and it would put me in the second quadrant, which would give me 3 pi over 4. Okay. The negatives would put me in the third and the fourth quadrant, so I'd have 5 pi over 4, and then I would have 7 pi over 4 in the fourth quadrant. And since there are no restrictions here, plus 2 pi n, plus 2 pi n, plus 2 pi n, and so on. Okay. Now, if you notice, there's actually a little pattern here. Okay. From pi over 4 to 3 pi over 4, to get from there to there, I've really just added 2/4, which is pi over 2. Okay. To get from 3/4 to 5/4, that's another addition of pi over 2. And there's another addition of pi over 2. And if I add 7/4 and I add 2/4, that puts me at 9/4, which would actually take me right back to the pi over 4 spot. So I could kind of condense this down a little bit, and instead of doing all 4 of them and adding 2 pi, I could really go with pi over 4 plus pi over 2n. Okay, so that concludes our first intro into solving trig equations. So hopefully you've kind of getting the hang of that a little bit, and we'll work on some problems and answer questions in class. So we'll see you in class tomorrow.